So we're gonna do a prefix sum problem. Usually they're like hidden in disguise. So they're fun to do. Let's shuffle. We're gonna tag to go for a medium. Oh, I've done this one before. Let's do a different one. Okay, cool. Medium, and then this is this seems kind of hard. No problem. So we're given a matrix, positive integers, and we're trying to determine is it possible to make a horizontal or a vertical cut? So this is a horizontal cut, this is a vertical cut, such that basically the sum of the elements in both sections are equal. Can I cut this? 1 plus 4 is 5, 2 plus 3 is 5. Okay, it seems like a very simple problem, and I like it. So I'm gonna draw it out on paper you can't see. A little bigger of a test case so we can see really what we're dealing with. So let's see. 1, 4, 2, 3, 1, 1, 1, 1, 0. It's all positive integers. So 2, 1, 4, 5, 1, 2, 3, 4. Right? So in this case, I can make 8 possible cuts, right? 1, 2, 4 vertical cuts. If I have 4 by 4 grid, I can make 3 vertical cuts, right? Because you only have 2 sides, so you can't do on the edges, and you can also do 3 horizontal cuts. And you can only make either. So that is cool. So the brute force, right, is to make all those cuts and then calculate the sum. Now, we want to figure out, right, that when I make a horizontal cut, so for example, if I make a horizontal cut at 1, 4, 2, 3, right? And I calculate this, so I calculate this sum, and I calculate this sum, right? Then, when I do 1, 4, 2, 3, and 1, 1, 1, 1, and I move my, horizontal cut down, now, what's happening is, I made a horizontal cut, so I'm checking the new sum of my first 2 rows and the new sum of my old 2 rows, right? So one way to think about it might be with adding 1, 1, 1, and with removing that 1, 1, 1 from the other side now. And we're saying, is that possible? Right? But so we could do something like that. An even easier way to think about it that uses less brain cells is do a prefix sum on the rows. Right? Instead of doing a prefix sum on individual numbers like we do in an array, do it on rows. And then it's the same idea for columns. So here's the idea. Prefix rows, and I'm gonna just call that this, right? So what's the sum for the first row, sum for the second row, third row, and usually in this is just template prefix sum code, which is like for row in grid, prefix rows dot append, not append, usually we say I plus 1 equals, and usually we do 0 times, so we can say length of, or in this case we want to find what? Prefix rows for every row. How many rows are there? That's just length of grid. Num rows. We're going to say num. So we're going to say rows calls length of grid 0. And then we can say 0 times the number of rows, prefix of those of I plus 1 equals prefix those of I plus the sum of the, right? See if do. And now note that this should be those plus 1 because you're going to have all of those and you're going to have that initial 0. That, cool. And then now we just make all of those different horizontal cuts, right? So like we would say make a cut where like I didn't make a cut at, so you can make a cut at 1, at 2, at 3. So what we're gonna say, so the cut in the range, those 1 comma those. It's gonna, it's saying like we're making a cut. We're making a cut at the bottom of the first row, the bottom of the second row, and then you prefix those. We want prefix those of just all the way down to what? To cut, right? So if we're looking at 1, 4, 2, 3, we want that sum, which would be prefix those cut minus that's everything above, and then we want to see if that is equal to everything from the bottom, right? Everything from the bottom, which is prefix those of the end of the end, which is just those, the last row, minus prefix those of cut. Right, so everything minus the rest. Right, and then we can say if this is true, return true. And we literally do the same thing for columns. This handles like a horizontal cut case, but if you want to consider the vertical cut case, you could just say prefix calls is 0 times calls plus 1, and then you'd say what? How would you do this then? Because now you're trying to sum up instead. 1, 2, 4, 3. Right? So you could say for call in range calls, if I'm on 0, I'm trying to find the sum of everything in the first column, like everything in the first column of the first row. So like I would say for row in rows, I would like sum over grid of row comma whatever my call is for row in range rows, and then I would sum over this to find my column sum for that column. And then I would say prefix calls of I plus of call plus 1 equals prefix equals what? Prefix calls of call plus calls. That is how I find my vertical cut case, and then I can just say for cut, I can just do the same thing, right? In range 1, comma calls, if the calls the tensor, right? And then if none of this is true, false. So let's run that to see if that works. Global name I is not defined. Oh. Let's do for I, comma low, and enumerate. Cool, submitted, and then let's try submitting this. No! Something we messed up. Let's see. Oh, why did I keep this as prefixes? Those still. Calls. 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 Submit. Awesome. We beat it, and one easy way to optimize this is you can create your prefix calls like this, sure, but this, you could literally define a function to do it. But, I mean, in LeetCode style, you could just do it really fast and paste in the place. But awesome.